Hi, my name is Corey Feldpausch. I am in a group with Douglas Hall and Patrick Gatsby, and we are presenting the facts behind 3 Mile Island Unit 2. I will be presenting the days following the accident, the cleanup efforts, and the effects on nuclear power industry. We begin Thursday, March 29th, 1979. The crew had made it past Wednesday, in which the events occurred. They were optimistic that they had placed the reactor in a stable condition, and Thursday was going to be a day of interviews and briefings in which the vice president of MET-Ed informed the public that he believed only 1.5% to 1% of the fuel rods experienced some damage. We also have NRC arriving on the island today. They were briefed of the conditions and reported back to headquarters saying it all seems to be over. This could not be further from the truth. Victor Stello, an NRC representative, was one of the first to believe that there were superheated steam conditions inside the plant and that the core may be uncovered. His superiors ignored his concerns, yet when asked why there were temperature differences inside the system, they contributed them to steam binding or a bubble somewhere in the system. Later on, wastewater becomes a concern. Wastewater are things like showers, toilets, sinks. They had secured all pumping overboard once the accident had commenced, and at this point their tanks began to fill and they needed to get rid of the water. They began pumping the water into the Saskatchewan River, and when the governor found out about it, he immediately made them secure the discharge. At this point, they'd already discharged 40,000 gallons into the river. They had also performed samples on the water to verify the radioactive content of the water, and it was well within federal standards. Once the discharge was secured, they began experiencing tanks approaching full again, at which point they informed the governor of the issue and he allowed them to pump them overboard. Around 2 p.m., Richard Wilson and a group of engineers from the General Public Utility Service Corporation arrived on the island. They are quickly brought up to speed on the accident, and Richard Wilson requests to speak with the crew. Following the interviews of the crew, Wilson realizes that the situation is way worse than they are informing others, and he believes that this is a plant nowhere near a cold shutdown condition. Later that day, they begin reviewing the pressure logs, in which they noticed that the thud they experienced the day before with the increased pressure was actually a hydrogen explosion. And at this point, they were informed that the crew members were receiving 1,000 rem per hour on sample bottles, and they were receiving 3,000 millirem per hour radiation surveys above the at about 15 feet above the cooling stacks. At this point, Richard Wilson informs his superiors that things are way worse than thought, and they began investigating. Friday, March 30th, the NRC believes that the letdown system is leaking. They believe that they have uncontrolled release of fission products to the environment. But the concern begins when the makeup tank begins to fill, and due to the makeup tank being at a lower pressure than the primary system, gases are coming out of solution, and the crew fears that the relief valve, which is set at 80 pounds, may open, allowing radioactive water to be let out into the auxiliary building. So they realize they must burp the makeup tank into the waste gas decay tanks to minimize the release to the environment. They use the waste gas compressors to control the gas that's leaking, and they cycle the vent valve open and shut as necessary but over time they realize they cannot control pressure and decide to leave the valve open for the time being. Realizing that they're releasing fission products to the environment, the supervisor requests that Unit 1 send out a group to perform radiation surveys above the stack and at the boundary. At about 130 feet above the stack in a helicopter, they received 1200 millirem per hour radiation readings. At the boundary, they're reading 14 millirem per hour. And the supervisor believes that he needs to inform the Pennsylvania Emergency Management Agency to inform them of the release, and he informs them to prepare for evacuation. And of course, the Pennsylvania Emergency Management Agency takes this very seriously. Yet later on, the supervisor testifies that he was just testing their readiness. The NRC at this point has no idea that the crew is releasing fission products into the environment, but they are concerned about the waste gas decay tanks filling up. And Lake Barrett, an NRC official, decides to calculate how much exposure to the public may be received if the relief valves on the waste gas decay tanks opens. He calculates it to be 1200 millirem per hour at ground level if that relief valve opened. And within 10 to 15 seconds of him calculating this number and informing others, the NRC is informed that the waste gas decay tanks are full and that radiation levels are 1200 millirem per hour. Yet they do not know where that survey is taken. They just know this 1200 millirem per hour is received. And fearing the worst, the NRC takes action. What we need to remember is that the waste gas decay tanks are not full, and the surveys at the boundary are 14 millirem per hour, so the information that the NRC is receiving is incorrect. There are two other officials that know the origin of the survey, but when trying to stop the evacuation, they experience problems, not being able to get people on the phone, situations like that. But the PEMA director, Orrin Henderson, informed Lieutenant Governor Scranton of the issues that they believed were true and informed them they should evacuate, at which point Lieutenant Governor Scranton goes to brief Governor Thornburg. And while this is going on, the PEMA director just assumes that Governor Thornburg is going to evacuate, so he informs radio stations and firefighters to prepare for evacuation if you're within a 5-mile radius. Radio stations begin broadcasting to prepare for evacuation, and at this point the crew hears about the evacuation order. They immediately call the NRC to ask why the evacuation is being called, and after a short discussion they agree that it's unnecessary. At this point the NRC chairman, Joseph Hendry, briefs with Governor Thornburg that the evacuation is unnecessary, but he still believes that people within a 5-mile radius should stay indoors. The governor begins to be a little conservative, and he wants individuals in a 10-mile radius to stay indoors. And shortly thereafter, they send out an advisory for pregnant women and children to evacuate. So now the public has been told to evacuate, not to evacuate, stay indoors, pregnant women evacuate. And to make this way worse, a movie was released about 12 days earlier called The China Syndrome. In this movie, Jane Fonda is a reporter, and she witnesses a reactor accident at a nuclear power plant, and when she tries to inform the world about it, they prevent her. So the public has seen this movie, and they begin not trusting what's going on, especially with the evacuation orders. And to make things even worse, when officials are asked about this 1200 millirem per hour reading they received, they kind of dismiss it and say, no, we only received 300 to 350 millirem per hour. We're not sure of where you got this 1200 millirem per hour. So of course the public begins being really scared. The evacuation begins to grow. It goes to a 20-mile radius at one point. They begin to close schools. At one point, they believe that there are 6 counties under an evacuation, to include 650,000 people, 13 hospitals, and 1 prison. The director of the NRC, Harold Denton, becomes the president's right-hand man and his direct voice on the island. When he arrives, he realizes the severity of the accident, and he realizes that there is a bubble in the core. He sets a team out to determine the size of the bubble, and they believe that the hydrogen content of the bubble is not a concern, but he realizes they must use degas and other types of methods to reduce this bubble in the core. He also informs the governor that the evacuation is unnecessary. He gets him to secure the evacuation, but the governor maintains the pregnant women and children evacuate. We now move to Saturday, March 31st. NRC Chairman Joseph Hendry, he's a very well-respected person in the NRC. He's actually one of the only personnel there that has any experience. So he's one of those people that when he talks, people listen. Well, he can't stop thinking about this hydrogen that's inside the bubble. He's realizing that more hydrogen is being produced from the zircaloy cladding. He realizes that zircaloy, when it's in a high temperature steam environment, it will react with water. The oxygen combines with the zircaloy and the hydrogens combine to form hydrogen gas. But they believe that it's not going to combust because they don't have oxygen, right, to make it combustible. Well, he then realizes that there's radiolysis of water. So now the water inside the coolant system is forming its own oxygen gas, and he believes there's a major concern here. Hendry and a group of individuals calculate that there is oxygen being produced, but there's varying amounts in their calculations. He informs Harold Denton of his findings, who actually kind of dismisses him, and informs the governor and the public that there's no risk of a hydrogen explosion. But of course, Hendry took it upon himself and informed the press that a hydrogen explosion was imminent and there's going to be a potential 10 to 20 mile evacuation. So of course, just like before, it's adding to fears. People don't believe him. They realize there's dissension in the ranks. Denton does what he can to calm them down, which doesn't really work. But the president will come tomorrow and things will change. With the president on his way to the island today, Sunday, April 1st, the NRC makes it a point to determine whether or not this hydrogen is explosive. A group of them do certain calculations, and they determine that there is about 5% oxygen inside the system, and it is growing at about 1% a day. So at right now, it is not explosive. It is flammable, but not explosive, and it will be explosive in about 6 or 7 days. Hendry then consults with Westinghouse Bettis and General Electric San Jose, and they inform him that hydrogen is typically used inside primaries to scavenge oxygen, and that the hydrogen inside the plant is probably scavenging this oxygen like it's supposed to. Therefore, there should be no concern. Hendry realizes this, and his concern is now over. President Carter was the perfect president to be in the office during this accident. He was prior nuclear Navy, so he understood nuclear operations. He understood that the public feared nuclear plants. Therefore, he went to the island because he knew his presence would calm the public. He did a quick tour, did some photo ops, and when he left, he informed the public, hey, the plant is stable and that it'll soon be in shutdown, and there was not an accident. We saved it, is what he told them, and he needed their full cooperation and understanding for all future events. With the hydrogen scare now over, the crew attempts to remove the bubble through degas. After about 2 days, the bubble is confirmed gone, even though there are reports that it was gone a day or two before that. At this point, the governor lifts the advisory for the evacuation of pregnant women and children. And 1 month after the accident, on April 27th, the plant reaches cold shutdown. The investigation now begins, and this will be discussed in a later presentation by Patrick Gadsby. In August 1979, the cleanup begins. They plan out a 3-phase method of cleanup. They are going to work on the auxiliary building and fuel handling building tanks. They then work on the reactor containment building, in which point they move on to defueling and decontaminating the primary system. And the estimated costs were going to be roughly $1 billion. In the auxiliary building and the fuel handling building tanks, there's approximately 280,000 gallons of radioactive liquid. They remove the water and process it through filtration and ion exchange. They then store it in a tank and got approval to boil off the water over a 2-year period. They did it such a slow time frame to minimize the exposure to the public. They calculated that it was roughly equivalent to a normal annual dose rate due to things like cosmic radiation, radon, and other natural occurring elements. The reactor containment building has 3 subsequent phases. In the basement of the reactor containment building, they have approximately 700,000 gallons of radioactive liquid. Like the auxiliary and fuel handling building tanks, they remove the liquid and store it in a tank and process it and boil it off in the same manner. This is finished December 1979. The building itself was maintained at a negative pressure because of the mass amounts of krypton-85 in the building. So the second phase was to remove this, and it was finished in July of 1980. And then there was an extensive effort to clean all surfaces of contamination inside the entire building. They then moved down to the primary system. They realized they needed to defuel the plant and decontaminate all surfaces, but at this point they had no idea what they were dealing with. So in 1982, they sent robots into the primary, and using cameras, they discovered that there was a 5-foot gap or a void on the top portion of the core, and in the bottom they saw melted fuel on the bottom of the vessel. At this point, Roger Mattinson, the senior NRC engineer, explained that we had a meltdown. 50% of the core was destroyed and molten, and something in the order of 20 tons of uranium found its way to the bottom head of the pressure vessel. That's a core meltdown, no question about it, is what he said. This is just a picture of the containment used to house the fuel, at which point they placed the fuel inside of this container and shipped it to Idaho, where it was buried. Using the information gathered by the robots, this was the end state configuration of the core, in which point you can see the large void at the top of the fuel cell, all the melted fuel, and then at the very bottom you see the fuel at the bottom of the vessel head. So now the question becomes, how did this accident affect the nuclear industry? We know that the NRC, they tightened regulations, they altered control room layouts, they improved the licensing process, and they improved training programs, which all cost a lot of money. Due to the changes by the NRC, plants under construction experienced excessive delays due to the modifications that were required now by the NRC. The cost of the plant construction went way up. In the 1970s, it was around $170 million to construct a plant. Yet in the 1980s, it went to $1.7 billion. Labor costs went from 38% to 52%. And during this time, around approximately 100 plants canceled their order for construction of a plant, and around 40 plants canceled their plant during construction phases. But was this decline in construction really the fault of 3 Mile Island? Many experts say no. Certain experts blame it on the oil embargo of 1973, while others blame it on the ratcheting techniques of the NRC on their regulations. In the early 1970s, the public was very untrustworthy of the nuclear power and its safety. So to combat the public, the NRC made stricter regulations. And using these ratcheting techniques, they made things harder and harder and harder and never loosened up. Therefore, like a ratchet, just always tightening, never loosening. So as you see in this graph, around 1973, things start going down all by themselves, at which point 1979 is when the accident happened. So you can already see, well before the accident, things were on a decline in the nuclear industry, and it is not solely due to 3 Mile Island. Thank you for listening to my presentation on 3 Mile Island. I'll now turn it over to Patrick Gatsby, who will go into the investigation of the accident and the lessons learned.